If you're into the science, you may know that there are so many topics which are baffling to understand, especially in physics. That's the reason why we join classes and all that stuff. But in this video, I'm gonna try to explain the terms centripetal force and centrifugal force. Well, first of all, these terms, centripetal and centrifugal, comes when there's a circular motion going on. Now, the word circular motion is not new to us. We know these kind of motions like linear motion, oscillatory motion. Even a child from 5th class would know about these motions. Since the centripetal and centrifugal force comes into the play when there's a circular motion going on, we gotta get to know the circular motion better, as opposed to linear motion, which happens in straight line, forwards and backwards, along with either horizontal or vertical axis. The circular motion takes place when a body is moving in a circular path, keeping the consistent distance from the center of the circle. Now, at this point, we can say for sure about the magnitude of the velocity, but the thing that we know for sure is its direction, which is constantly changing. Why? Well, it's obvious. Just look at any point of the body which is doing the circular motion. It doesn't go in a straight path. It takes turns again and again in order to make a complete circle. From this observation, we know right out of the gate that the direction of the particle doing circular motion changes at every instant. So what does that mean? It means that in circular motion, the velocity is constantly changing. But what about speed? Well, it turns out that speed may be constant or may not be, since speed is just the magnitude of the velocity. If it's given that the speed is constant, that just means the motion is in a uniform circular motion. Now, if there's a circular motion in which the direction is changing, which obviously happens in all cases, then there's gotta have an acceleration. Meaning that in a circular motion, it is designated to have an acceleration unless you're not talking about uniform circular motion. And if there's an acceleration taking place due to change in direction, then it's termed as centripetal acceleration, which is denoted by A sub c, in which A stands for acceleration and C stands for centripetal, or A sub r, in which A stands for acceleration and R stands for radius. Its formula is V squared divided by R, which is also equal to R omega squared, where V is the velocity, R is radius, and omega is angular velocity. At this point, we know that there is a centripetal acceleration in circular motion because of the change in direction. But there's gotta be some sort of force which is providing the centripetal acceleration, because this centripetal acceleration cannot come on its own, can it? So the force that provides the centripetal acceleration is called the centripetal force. But here's where things get a little interesting. What if I say that the centripetal force does not exist? Sounds strange, doesn't it? We know that in physics there are a total of 4 forces of nature, which are gravitational force, strong nuclear force, weak nuclear force, and electromagnetic force. The centripetal force does not belong to any of these 4 forces. So what exactly is the centripetal force? Well, let's get a deeper dive into this. Let's take an example. Here's a ball rotating a stone attached to a string. How many forces are acting on that stone? There's obviously gravitational force, and then there's a tension in the string which is holding the stone in its path and causing it to move in a circular path. So here, the tension in the string is providing the centripetal acceleration, and hence the tension in the string is the centripetal force in this example. Just like this, we can take many examples, like motion of planets. While the Earth is rotating around the sun's gravity, which is causing the Earth to rotate around it, is the centripetal force. Also, in an atom, the intermolecular forces of attraction, which are holding the electrons in their place, is called the centripetal force. So, in short, the force which is causing the object to move in a circular path and is directed towards the center around which the body is moving is called the centripetal force. Now, what is the formula of the centripetal force? It's simple. We know the formula of the force from Newton's second law, which is F equals ma. We can replace the force F with the centripetal force Fc and acceleration with the centripetal acceleration. And just replace this with either V squared by R or R multiplied by omega squared. Then the formula of the centripetal force becomes Fc equals mv squared divided by R. Now, is it an imaginary force? No, it's a real force. See, the examples I mentioned earlier, in all those examples there is a real physical force acting on them. The forces are in different forms, but they act as a centripetal force. All those forces do the same thing of keeping the object in a circular motion. Hence, these forces are called the centripetal force in those circumstances. Now we know that the centripetal force is just a force that acts on a body moving in a circular path and it is directed towards the center around which the body is moving, which is the definition of the centripetal force. Now that we're done with the centripetal force, let's understand what centrifugal force is. In order to understand the centrifugal force, we should know that the centrifugal force acts only in non-inertial frame, sort of like pseudo force, which acts in the instances where Newton's laws don't work. That is, in non-inertial frames. You might be familiar with the inertial and non-inertial frames. Let's just recap them. We can say that an object is in the inertial frame when we observe that there is no force acting on the object and has zero net force on it, and most importantly, zero acceleration, or the object is moving with a constant velocity. As for the non-inertial frame, the object has an acceleration but still doesn't have any forces acting on it. For example, when we are standing on the ground and watch any object which is not moving, we can see for sure that the object is in the inertial frame. As opposed to this, anything which is moving with our frame of reference, that is, with respect to the Earth, is called a non-inertial frame of reference. Back to our centrifugal force, it acts in circular motion, and since it takes place only in non-inertial frame, you'd only see that force when you are in that non-inertial frame that is moving in the circular motion. Let's understand this with an example. Let's suppose that you're driving a car. You are in the non-inertial frame with respect to the Earth, or any person standing on the Earth, and you're not moving in that car. So that means you are in the inertial frame with respect to the other person sitting in the same car. Now, if the car makes a turn to the left while taking the turn, you, along with the other person sitting in the car, will experience a force towards right. This force is called as a centrifugal force. Now, it's important to note that this force is not applied by any physical body, because you were moved towards right by yourself only, since nobody applied any sort of physical force on you. That's why the centrifugal force is also called as a fictitious force, as opposed to the centripetal force, which is a real force. Another example of centrifugal force would be passengers feeling pushed outward force on a merry-go-round, and the stone rolled round a string, and when it's rotated in a circular motion, the force that the stone feels is the centrifugal force, and the person who's rotating the stone also feels this force via string. In the game called tetherball, where the ball is attached to a pole and it's given rotation by the players, the force that the ball ends up experiencing is called the centrifugal force. Since this centrifugal force is also termed as a fictitious force, it means that it's an imaginary force. But here's where things get a little confusing. If this force is imaginary, then why do the objects move in all those examples in the first place? There's gotta be some kind of force that's taking place there. In order to understand that force, we need to go back and observe things from the inertial frame. Observing the first example from the inertial frame, we get to know that it's just the inertia of those people which is causing them to move towards the right. Do you remember Newton's first law? The law of inertia, which states that if a body is in motion, it continues to be in motion, and if a body is at rest, it continues to be at rest until and unless an external force is applied. So in this example, there's a sudden change of direction in the path of the car. Before that, the car was going in the straight line, so were the passengers, and when there's a sudden turn, the car changes its direction, but the passengers are still going in the straight path. So because of the sudden change in the direction, passenger's body kinda jerks in the opposite direction of the turn. And this inertia is termed as a centrifugal force in circular motion. So basically, the centrifugal force is the inertia of the body. It's just renamed as centrifugal force to make things easier while studying the circular motion. So this was my mere help, guys, to help you understand the concept better. If you found this video informative, please leave a like below and subscribe for more of this content.